So natural log x prime is 1 over x. This, again, I did not see it in any example. If we come across it, I will teach you that formula as well. But now we want the natural log if this is a function. See here, I should have said times the inner function prime. Why I did not? Did I make an error?
It would come out to 1.
Because it's 1. But now this is not x, it's anything else. So how will I write the formula? And then we can go ahead and practice.
Is it 1 over f times f prime?
Absolutely. Good. That's it. So we are on page 216. Can I reach my keyboard from here? I think I can. So let's practice this and then look at word problems. You choose.
Should we do 1?
Yes. Y equals -9 natural log x. Don't let Tess choose other problem. I'm kidding. I'm kidding. I'm absolutely kidding. Good. So this is a nice one. -9 will stay patiently, and I have to differentiate natural log.
One over it.
That's it. That's it. Very good. Good. Anything else? From 1 through 20. Through 23. Find the equation of the line tangent to the graph. We have to work on that as well. And then we'll look at a word problem.
Maybe like 21. Maybe.
21 it is? Is that what you said, 21?
Yep.
21. 21, let me copy it. Make sure I copy the correct. Okay, y equals natural log x, everything squared, at x equals 3. So, find the equation of the tangent line to the graph of this function at x equals 3. When I'm asked to find the equation of a line, I write immediately y minus y1 equals the slope times x minus x1, where I know that this is 3. How do I get this? And then I'm going to ask you, how do I get this?
You plug in the 3.
Of course. Of course. So this number is f of 3. This is also the same thing with f of x. F of 3 will be natural log 3 squared. Do not calculate that. Leave it alone. So I have this piece and I have this piece, but now how do I determine this? We've had these situations before, not with this function, but with other functions. So how do I find the slope? What do I have to find first? The derivative, yes. This m will be f prime of 3. Awesome. But I have to find f prime of x. Or if you want y prime, it doesn't matter. Good. I have a function to a power, prime. What do I write? Two times the function to 2 minus 1 times, if I forget times the inner function prime, I'm in trouble. Times what?
One over x.
That's it. So now f prime of 3 will be 2 natural log 3 over 3. Yes, I know it's weird. Yes, I agree. So I have this as being this. Messy, but doable. Good. So I have y minus natural log 3 squared equals this number, 2 natural log 3 over 3 times x minus 3. And no, I will not approximate these numbers. Absolutely not. So I will distribute here. So I have 2x natural log 3 over 3. I will distribute here, and I get negative 2 natural log 3. I will bring this over as natural log 3 squared, and I will just leave it alone as is. That's it. I'm not going to do anything else. So when I multiply these two, I got this. But when I multiply these two, the denominator disappears. I only get negative 2 natural log 3. I have to bring this quantity to the other side. It's negative here. It will become positive. And that's it. Okay, let's look at a word problem. We can come back and differentiate other things here. It was a very good pick because basically we looked at something like this. I know I'm looking, where is my time? I don't know. Where's my time? Okay, 7 minutes. I'd like to finish one word problem. Advertising, walking speed, heating water, warming a frozen package. See how many applications. This log function is tremendous. And the exponential also. Population. You want to talk about the population? Bird population?
Yeah, we can do that one.
Okay, so let's take a look. They're all the same idea. So T is in months. Please take notes. Birds, okay. Individual, okay. T of P. Okay. P is number of birds. P, number of birds. Fine. Equals 38. Natural log of 4,500 over 7,500 minus P. Fine. And they say that okay, so what is this uppercase T now? Where is uppercase T? What is this? I have no idea what this means. There's no T. Let's continue. Find T of 5,000. So T of 5,000, and then T prime of 5,000. And what is the population of birds after 5 years? And B, the time T in months needed for the population of the birds on an island to reach P individuals. And what is the population of birds after 5 years? It's very interesting how the time depends on the number of birds, really. I think they messed up something here, but it doesn't matter. I just want to talk about T of 5,000 and T prime of 5,000. That's all we really are interested. But this is, time does not depend on the number of birds. So how is it possible that T is a function of individuals? Never mind. Okay. So in order to determine T of 5,000, we only have to plug it in. So we're going to do that in a minute. But how do I get T prime of 5,000? That's what I'm interested in. So first I have to find t prime. So let's find t prime of p. The constant stays outside. Now I have natural log of a function, prime. What do I have to write first, before I even look at the function?
Professor Lee,
Yes.
you're being cut off.
I am?
I don't know if it's my computer or everyone's.
It could be at my end. It happened before. So it's 1 over this times this prime. I'm going to write it like this for a moment. This is flipped. Because that's how I divide by a fraction. And now, careful, because the numerator is a constant. It is best to change this into 4,500 times 7,500 minus p to -1. It's okay if you want to use the quotient rule. That's fine too, if that's what you want.
What did you just do again?
I changed this, but we don't have to, because the numerator doesn't have a variable. It's a constant. So I changed into 4,500 times this to power -1, because it's in the denominator. If that confuses you, we just have to use the quotient rule. But when I differentiate this, I get 0. So then minus 4,500 times this prime, which is -1, over this squared. So sometimes this is confusing because it doesn't have a variable in the numerator. So you have to say this prime is 0. So it's 0 times this, 0, minus this times this prime, which is -1. So be careful with that. I can simplify one of these. These become positive. So I have 38 times 4,500. Oh, sorry. 4,500 is going away. Divided by 7,500 minus p. And all I have to do is just plug it in. So what I did, one of these went away. 4,500 went away with this. -1 with -1 is 1. 38 over the denominator. I will put these functions in and plug in 5,000. And find the time in months.
4,500 minus, if it is prime, it's going to be 0.
Yes, so there is a 0 in front here. The top function prime is 0 times the denominator, so it's 0. Minus from the formula, the numerator times the denominator prime, which is -1. So that's why it's confusing. Sometimes the quotient rule is confusing when the numerator, it could be confusing, not necessarily, but when the numerator is a constant. So we can stop here. I know it's time, but I would like to finish it, but you don't have to stay if you don't, if you're busy, or if you have to go, you have to go. I fully understand. I respect that. But I want to finish the problem. So in y equals, clear. So the numerator, the function is 38, natural log, and in parentheses we have 4,500 divided by, in parentheses, mandatory, 7,500 minus x, close and close. The other one is easier, 38 divided by, in parentheses of course, 7,500 minus x. All you have to do is plug in 5,000. Good. So 22 months, and the rate of change is 0.0152. So the first one, 22.336 months. And this one is 0.0152 month per bird per individual. I think they tried to do something else with this problem. Something must have gone wrong there. So the time for the population to become 5,000 is about 22.336 months. And when the population is 5,000, the rate of change is 0.0152 months per bird. Really?